What's going on, everybody? This is Mr. Diamond, and today we are going to be starting Chapter 4, Nomenclature, Naming Compounds, and Writing Formulas for Chemistry. Now we're going to start with the easiest possible thing that we could have to do in this class. It's not usually going to be super relevant, but it's going to be a building block that is going to allow us to step up and kind of learn more of the material here. There's going to be a lot of stuff in naming. This chapter can kind of be the first phase of the downfall for some people if they don't start taking this class seriously. So if you are not at the point where you're kind of feeling like you've had to try very hard, this is the point where every chapter we talk about for the next, I'd say 3 to 4 chapters, almost every single piece is going to be needed to keep going through the rest of the class. You have to know all of the stuff from this chapter, every bit of naming that we talk about here, because then we're going to use that naming to do chemical equations in the next chapter. And then you have to know how to do chemical equations, because then when we do that, we're going to be doing problems in math related to those chemical equations. So we're getting to the point that this is absolutely critical that you understand how all of this stuff works and that you understand what is going on in each of these examples. So coming back to that, make sure you're feeling good about all this. Make sure you ask any questions, send me emails. We're going to start with the easiest possible ones, which are monoatomic ions. Mono meaning one, atomic meaning atom, and then ion meaning a charged particle. There are 2 types of these, cations and anions. Cations are positive, because cats have paws, and they're formed when atoms lose electrons. They are usually metals. Anions are negative ions, formed when atoms gain electrons, and they are usually nonmetals. Remember, metals are below to the left of the staircase on the periodic table. Nonmetals are above and to the right of the staircase. There are a few locations that always have the same charge. Group 1A, that is a cation, is always +1. Group 2A is always +2. And the A's are not super relevant. Really what we're talking about here, make sure I've got a periodic table close by I can hold up. We are just talking about the first column here. I hope I'm in screen. I'm not 100% sure if I'm on screen. We've got 1 and we've got 2. This first one is always +1. These are always +2. And then there's AL, ZN, CD, AG. Those are always +3, +2, +2, and +1. To name these, you just say the element name and then you say ion. So what is Na+? Na+ is a sodium ion. What is barium? Barium or Ba2+, that is a barium ion. Any of those are just element name, ion. There's no number, there's no modification to the ending, there's no prefix, no suffix, no anything. Transition metals and p-block metals, though, can have multiple charges, so you have to include a Roman numeral for those. So what we're talking about here is this middle chunk of the table here with those exceptions excluded, and then this bottom piece of the p-block right here. Now, you might be wondering why we use Roman numerals, and the main reason is because we want to use Roman numerals for charge and numbers for amounts in most of what we're dealing with here. So when we're doing a formula, you don't want to say there are 5 mercury 4s, and then you have a number 5 and you have a number 4, and then it gets really, really confusing. So we would use 5 with the Arabic numerals with like our number 5, and then we would use 1 or 4 or whatever number we're caring about with the charge. We use the Roman numerals. We use the I, V, all that stuff. If you aren't familiar how to do those, I can help you figure it out. You can Google it. It's pretty straightforward. I is 1, II is 2, III is 3, VI is 4, V is 5, VI is 6, or did I say IV is 4? IV is 4. Yeah, V is 5, VI is 6. It's easier to do it when I'm actually writing it down. Trying to say them out loud is a little bit weird. But you can Google it. You're only really ever going to go up to like 6 or 7. It's not going to go any higher than that. So in this case, Hg with a plus, that's mercury. But because mercury is in this lower section of the table, because mercury is in the D block, we have to call it by its charge as well, because mercury could be multiple possible charges. So we say mercury 1 ion, or a mercury I, Roman numeral 1 ion. Chromium is up here. It's on the top of the D block as well. Chromium with a +5 charge, we would call that a chromium 5. But again, we use a Roman numeral 5, so it would be chromium V ion. We would say chromium 5 though. You don't say mercury I ion or chromium V ion. You say chromium 5, mercury 1. You're just trying to indicate that number when you write it is a charge and is not a amount. Now for anions, you change the ending of them. So this is how we distinguish when we're talking about something. You may have realized, like, well, for sodium or barium, how do we know what charge they are? How do we know, like, what their formula is? Well, we know based on their position on the table that they have to be a certain charge. And then by not changing the ending, you're letting them know that it is a positive charge. Same thing here. Mercury and chromium don't have an ending change, so you're letting them know that they don't have, or that it's a positive thing. They aren't going to be having any negative charges. If you change the ending of something to an IDE and then add ion to the end, you now have something that has a negative charge. Again, notice you don't indicate the charge. The only elements, the only elements that you have to label the charges for, and you will get points off if you try to label them for other elements, is the F block, the D block, and this lower portion of the P block over here. This middle section, this lower section, and this little under the staircase area right here. Those are the only places where you are allowed to use the Roman numerals. Everywhere else on the table, you don't use them because we should know what they are. If you look at oxygen's position on the table, you should be able to figure out, okay, oxygen's right there. It's 2 steps away from being a noble gas, and it's 2 to the right that it has to move. It means it has to gain 2 electrons, which means it has a -2 charge. Now, your brain probably doesn't work that way because you're not a chemistry teacher. But you can at least go, okay, sulfur, it's above to the right of the staircase, that means it's negative. It's 2 steps away, that's a -2. But instead of saying sulfur ion, we would change that ending to an IDE. And instead of saying oxygen, we would change it to oxide. Selenium would be selenide, carbon would be carbide. I'm not going to be super nitpicky about like how close you get to the actual word. Like if you said carbonide or seleniumide or sulfuride or something like that, I would count it. I just give you like a side eye a little bit, like that's not exactly right. And after you do this long enough, you'll pick up on exactly how you're supposed to word it. But I'm not going to like count off points if your wording is a little bit weird. As long as you have the ending changed to an IDE and the word ion written after it, you are good. I'm not gonna yell at you about it. Okay, hydrogen, as usual, is our exception. Hydrogen can be positive or hydrogen can be negative. Hydrogen that's positive is a hydrogen ion, and it can only be +1 because it's only got 1 electron in the loose. And then hydride ion must be negative because it's trying to gain 1 electron. Hydrogen ions are way more common than hydride ions. They're just a lot more likely to show up in real life. Now, I think... yeah, we're going to stick there for a second. I don't need to go to the next slide. The last type of ion I could ask you to name is a polyatomic ion. And thankfully, you literally just have the list of the names. So if it showed OH- and asked you to name that ion, you would go, that is a hydroxide. Or I guess you could call it a hydroxide ion, but really you'd probably just end up calling it a hydroxide. Or if it was MnO4, you'd call that a permanganate. If it was ClO3, you'd call that a chlorate. If it was SiO3, you'd call that a silicate or a silicate. So any of those, you would just write whatever the name of the polyatomic is. If it is a metal, and it's in the Roman numerals section, or it's in the D block, the F block, or the lower portion of the P block, you have to include a Roman numeral. And again, you don't have to solve for that. Notice that in all the examples back here, I gave you Hg was a plus, Cr was a +5. You don't have to solve for that yet. We'll talk about how you can solve for it on some of the problems later, but for now I would just have to give you whatever that number was. If it's not in those sections, you just say, well, it's sodium ion, or it's a lithium ion, or it's a calcium ion, or it's an aluminum ion. Any of those work because they always have the same charge. And then if it's a negative thing, then you just say, you change the ending. Boron becomes a boride, carbon becomes a carbide, phosphorus becomes a phosphide, chlorine becomes a chloride. All of those, that "ide" ending, that changing to an "ide" ending, is what tells you that you're dealing with something that is negative. I hope that makes sense to everybody. If you have any questions about this, like I said, this is the easiest possible version of what we can do here. After a little bit of practice, you're probably going to feel really comfortable with this. It's probably not going to seem that bad. But let me know if you have any questions. In the meantime, this is Mr. Diamond signing off. Have a great rest of your day, everybody.